All right, today you're going to solve inequalities. We know how to solve equations. We look at what's being done in the variable, right? You add or subtract, you multiply or divide, you undo what's being done to it to solve for the variable. Today you're going to do the exact same thing except you've got inequalities, right? So it changes it slightly, and there's actually only one other rule you have to know when doing it. Hey, I actually tell my students to treat it like an equal sign 99% of the time, and then there's one case that you have to do something different, but the rest of the time you treat it like an equal sign. Today you're not going to see that case. I believe, I don't remember, I don't think they show it on this. Today all you got to do is you're going to solve it by addition or subtraction. So I look at what's being done to x, right, and I'm trying to get it by itself. So I draw a line through the inequality just like I would an equal sign, because what I do on one side I do the other, which I draw that line and I still have people like not doing it to both sides, or they'll do it twice to one side. One side on each side of the line, or one thing to each side of the line. I look at what's being done to x, I'm subtracting 12, so I add 12. I undo what's being done. So x is greater than or equal to 20. Right? What we're trying to do, normally when you're solving equations, you're trying to find out what x is to make it true. Usually x is only one number, like x was 2 or x was 4. Here, like a set of numbers make this true. You're trying to figure out what x has to be or what x could be. In this case, you found that x could be anything bigger, 20 or bigger, because it makes it true. And we can check. You can always check your answer. Plug in 20. 20 minus 12 is 8. Is 8 greater than or equal to 8? Mm-hmm. Yes. So it's a true statement. Plug in a number bigger than 20. 25. 25 minus 12 is greater than 8. Right? So you must have done it right. All right, write this one. 22 is greater than m minus 8. I'm trying to figure out what m is smaller than, right? To figure out what makes this true statement. So treat it just like an equal sign, m minus 8, so I add 8 to both sides. So 30 is greater than m. Okay, now they may, I think they do it, I don't remember. Okay, they do it later, I know. They'll switch the answer. So if you ever check your answer with the back of the book, the answer will be written like this. Right? M is less than 30. It's the exact same thing. So tomorrow when we're grading it, if I say one thing, don't be like, oh, I got this. It's the exact same thing, no difference. Okay? 30 is greater than m is the same thing as 30 is, or m is less than 30. Right? Same thing. Check your answer, find a number that's less than 30. Now let's go 20. 20 minus 8 is 12. Is 22 bigger than 12? Yes. So moving on. All right. You don't have to write this down. Just look at it for a second. I'll let you know this. They call it set builder notation. They write it like this. Like the answers, a lot of the answers will look like this. All it means is that for a variable of x, x is greater than or equal to 20. It's a really fancy way of writing x is greater than or equal to 20. Right? That's just the way they do it. So if you see this in the back of the book, don't be confused by set builder notation. Right? All I need is x is greater than 20. Notation. Write this down. So you might see a problem like this. This is just a multiple choice question, and the answers are in set builder notation. Again, set builder notation. This is actually how you read it. It's that all numbers, a set of all numbers m, such that m is less than 41. Right? Just a fancy way of writing it. Really, all you got to do is look at what's over here on the right side of that line. Okay? So what I want to do is I want to actually solve it. So I subtract 19 to both sides. I find that m is greater than what? 37. 37. So then I find my answer. That would be Charles C. Here they give you 3a plus 6 is less than or equal to 4a. Well, when we see a problem like this, right, our goal is always to get the variable by itself. But if you got the variable on both sides, what you have to do is you have to combine the variable. Well, if you've got a variable on one side, you want to move the other, you have to do the opposite. So if it's positive, you subtract it. Which I'm going to subtract 3a to both sides. Now I had trouble. My 8th grade, my pre-algebra students are solving for equations, and I was told them move the smaller variable if you can. Well, some of them took that literally, and they always did it. Well, this sometimes would be the smaller variable, which we try to eliminate negative variables, but sometimes you're just going to get them. But they would move this side over here, which then this side's equal to 0. We don't want to mess with that. Okay, find the one that's by itself here and move the other one. So I'm going to subtract 3a to both sides. So 6 is less than or equal to a. Right? Now it wants us to graph. So I'm going to put just a couple numbers that you don't have to make it neat or perfect. All right? Something easy like that. And it says 6 is less than or equal to a. So what I do is I put a circle around 6. All right? And I have to figure out, is this a closed circle or an open circle? What would it be here?
Open.
No, it would be a closed circle because 6 is less than or equal to. So when it's equal to, that's the closed circle. Just like in our homework, right? They had that open circle down at the bottom, right? And that's why it was not equal to. It was just less than or greater than. Okay? Only if that line's underneath there is it a closed circle. Then you got to figure out what's a number that is greater than 6. 7 or 8. So that's the direction you draw the arrow. We're shading to the right because a is anything bigger than 6 or equal to 6. Now, okay, my students in pre-algebra, we're actually talking about inequalities today, and they saw they actually the book wrote the answer like this: a is greater than or equal to 6, and they noticed that hey, this arrow is pointing this way, and this arrow is pointing that way. I can always go by the arrow. But if you had done that here, would you have got it right? No, because the arrow is pointing this way. The rule for that, and I tell them I don't really like them to do it this way, but I tell you the rule just in case, because most people do it anyway, is that you can only follow the arrow if the variable's on the left. Variables on the left here, you can follow the arrow. Variables on the right here, you don't want to follow the arrow. You actually go backwards. The easiest thing to do is just ask what is a number bigger than 6 and figure it out and go on. But kids like shortcuts, which really isn't a shortcut, but they see, hey, that goes with that and go with it. So I'm just bringing it up to you so you know if the variable's on the right, don't follow the arrow. Go opposite of it. If the variable's on the left, you can follow the arrow. Which I'll have students, they get this and they know, hey, that can't be right, so they flip it. No. So they took 2 extra minutes to flip it, and then they'll, hey, I'll draw the arrow this way. This doesn't make sense, but students do it that way. Hey, make sure the variable's on the left before you can use it. I want you guys to solve this one. I look at the inequality here. It's 5h is less than or equal to 12 plus 4h. So first thing I do is I've got to get h on the same side. So I would subtract 4h to both sides, which that leaves you with h. H is less than or equal to 12. So I put 12 in the middle, do a couple numbers. And then I know, hey, it's a closed circle because a is less, or because h is less than or equal to 12. And I know, hey, I look for a number that's less than 12. That'd be 10, that'd be 11, that'd be 9, it could be 2. Okay, so my arrow is going to be drawn to the left. Which I should check my answer. So what I do is I plug in a number that is less than 12. Let's go with an easy number. Let's try 0. 5 times 0 is 0. 4 times 0 is 0. Is 0 less than or equal to 12? Yep. Yeah, sure it is. It absolutely is. So h must be anything that's less than or equal to 12. Alright, write this one down. Alright, you see this? 9n minus 1 is less than 10n, so I gotta get the variable together. So I move this one over there. Negative 1 is less than n. So I would put a number line with -1, -2, let's go 0. And then I figure out it's going to be an open circle because it's less than, it's not greater than or equal to or less than or equal to, so it's an open circle. And I figure out what is a number that is greater than -1? 0 or 1 or 2 or 10. Because -1 is less than or equal to n. So the arrow goes this way. Now, just to remind you, the back of the book, the answer is not going to look like this. They're going to put it in set builder notation where they do n, they do a line, and then they flip it. The variable is always on the left in set builder notation, right? And they're going to have n is greater than -1. All right, and that's what that's going to look like. And that just means that for all set of numbers n, such that n is greater than -1. So, just what we're looking for. Any questions? All right, what you need to do is you need to write these down. These are the symbols, and they're phrases that they use for these inequalities. In case you see a word temperature or a word problem, not temperature, I'm looking at a problem. Where you see a word problem where they give you a description of an inequality and use one of these words to describe the inequality, and then you have to write it down. So you need to know what they're going to use. Right? For less than, they'll use less than, or they might use fewer than. For the greater than symbol, they'll use greater than, or they might say more than. For the less than or equal to, they'll say phrases like at most or no more, or less than or equal to. I've actually, in another word, a maximum. Okay, they might use maximum. For greater than or equal to, at least, no less than, or they'll just say greater than or equal to. Right? This would be a minimum. Right? That would be another word to use. And then here's your homework for today.